This video will be going over complex numbers, which is section 3.1, the very first section we do in this class. For a lot of you, this might be mostly a review, but just as a reminder, what we'll be talking about, what a complex number is, so what is I, pretty much simplifying complex numbers. There might be some new stuff in here for those of you. Probably not anything significant, but this might be the main new part. Then we'll talk about adding and subtracting complex numbers, multiplying complex numbers. And the last thing, which might also be new, is dividing complex numbers and something called the complex conjugate. So the first thing, the definition of a complex number. Pretty much I'll have most things that you should write down highlighted for your notes. There are maybe other things that you should write down. It's whatever you're comfortable with. If you're familiar with some of the stuff, even writing down a little bit can be helpful. Maybe you don't need to write down the whole thing. But a complex number is written in the form a plus bi, where a and b are real numbers and I is that square root of -1. One thing I like to go ahead and point out here that's very useful as well is that I squared, if we square each side, we will get -1. The squaring will make the square root go away. So typically we'll use these interchangeably just depending on what the question is, but it's important to know. Make this a little smaller, kind of thick. All right, so that's something that's also useful to point out. So here I have some examples of complex numbers. 2 plus 3i is a complex number where a is 2 and b is 3. One thing I didn't mention, let me go ahead and write it down. A is called the real part and b is called the imaginary part. You don't really have to memorize or know these definitions, but you might hear me refer to the real part and the imaginary part. The real part is just the part that's not being multiplied by I. So this first example, the real part is 2. 3 is the imaginary part, the part that's being multiplied by I. So in this first one, 2 plus 3i, the real part a is 2, the real part b is 3. Right, second example, just one with negative numbers, positive or negative, any real number is fine. So -3 minus I is also a complex number. The real part a is -3 and the real part b is -1. The third example here is one where there is no real part, it's 0, 4i. A number times I is still a complex number. The weird thing is that we don't often think about it, but a real number is also a complex number. It's a complex number where the imaginary part is 0. So example 12 is a complex number with a being 12 and b being 0. We won't necessarily use this very often, but it is a case if you're asked a question, is a real number a complex number with like 4 or something? The answer is yes. And then the last example I have here is just one to show you that the numbers don't have to be nice. We have numbers pi and e, got some decimals for them to try to understand them, but pi plus e times I is a complex number. The real part is pi and the imaginary part is e. Right. So since this is the first video, I want to talk about some of the things that I do in these notes very quickly. Like I said before, things that I highlighted are really what you want to write down. It's either going to be a definition like this. It's important to know the definition, because if you don't know the definition of some things, it's hard to say, how are you going to do it? How are you going to answer the question? A lot of the sections I will just describe how we're going to go through the answers, figure out how to do the answers. So anytime you have pretty much any number, you can simplify it to a plus bi form. The important thing is when you simplify to a plus bi form, you have to understand that when you have a negative inside a square root, you need to bring that out as I first. Exponent rules, which square roots are exponents to the 1/2 power, do not work if the inside is negative. You have to do this first. That's why I have that highlighted. Right, so this first one, I'll go through the intermediate steps for those of you that may not really remember. What we want to do first is write any negative number in a square root as -1 times that number. And negative 80 certainly is -1 times 80. And what we're allowed to do by exponent rules, as far as multiplication goes, is we can break it up over multiplication. So that rule is fine. We got -1 times 80. We have the square root, so we took the square root of each. And then the square root of -1 is exactly I. So I'm going to leave the square root of 80 alone for a second. What I want to point out here is that anytime you have a negative in a square root, if you go through these steps, you're always going to get the number inside positive with an I outside. And you can definitely use that shortcut. But you want to make sure you simplify it first, like this. All right, so once you have this taken care of, you have the I outside, your number's positive inside, then you just simplify the inside. Can we simplify the square root of 80? And we can, because this 80 is 16 times 5. Right, we're looking for those perfect squares. We break it up over the multiplication again. Square root of 16 times the square root of 5. And the square root of 16 is 4. The square root of 5 cannot be simplified. We got I times 4. And then the square root of 5 is simplified itself. Now you can leave it like this. I don't care where you put the I. You can put the I in the front, in the middle, in the back. Just don't put it under the square root. I think a lot of people like to put it in the middle. But you can have it in the front, you can have it in the middle, or you can even put it in the back. Just make sure you do not put it in the square root. But any one of these three is correct. I just want to add in a little note here. We do not put in square root by accident. Okay, so you put it in the back, but it's got to go outside of it. All right, number 2. Here we've got to simplify 4 plus the square root of 25. Same deal as last time. We want to focus on the square root first. I mean, as it stands, 4 is simplified. It's just the number 4. You want to simplify the square root of -25 first. We got the 4 in the front. The negative sign, if you break through and do the same steps as last time, the negative sign will come out of the square root as an I. And then we still have the 25 inside the square root. You want to break it down. Don't do too many steps at once. If you're not comfortable, just do one at a time. Next, can we simplify the square root? And we can simplify. The square root of 25 is 5. I'm going to write it. I like to write my I in behind the whole numbers at least. I usually write it at the very end, but it doesn't really matter. I like to write it like this. Now at this point, what you need to realize is you are done. This is simplified. This is our complex number. 4 is simplified and 5 is simplified. 4 is our A. You don't have to write this part down, but I'm just going to. 4 is our A, or our real part. 5 is our B, or our imaginary part. Now, one thing I like to mention about complex numbers is when you're dealing with them, when you're dealing with I, it works a lot like x. You wouldn't be able to combine 4 plus 5x. They're not like terms. You cannot combine things with I and things without I. They're not like terms. I'm going to go ahead and write that down. Right, so 4 plus 5i, what we're talking about here, this does not equal 9i. But I'm stressing the not equal part here. I don't, if you think you might get confused writing this, don't necessarily write it down. But this is simplified 4 plus 5i. It does not combine into 9i. Right, so the main thing that might be new here in this little section is simplifying something like this. If you follow the rules from above, it's not really any different, but you might want to do something that you're not allowed to do. So one thing you cannot do when we use the radical rule here to break up multiplication, we're allowed to go the opposite way. So the square root of 16 times square root of 5, we can multiply them inside the same square root if we were kind of reading this from right to left. But you can't do that with negative numbers. You have to do it with positive numbers. You have to take the negatives out as I first. Right, so the top, we got our negative inside square root of 30. It's going to give us I times the square root of 30. The bottom, we have negative 2 inside square root, so we got I times square root of 2. And we got negative square root of 5, which would be I times the square root of 5. Now, it's totally up to you how you go about doing this. I think the best way is to simplify the bottom together and then go through the top. So what I mean is I times I on the bottom is I squared. And the square root of 2 and square root of 5, since they are positive numbers, we can multiply them to get the square root of 10. And on the top, it's by itself. We got I times the square root of 30. Now really what you want to do here next, you don't want to think about I over I squared canceling an I out, because you'll be left with an I on the bottom, and you want an I on the top. Now to make sure you get an I on the top, what you want to realize is that I squared equals negative 1. And plug that in. We get negative 1 on the bottom. The square root of 10, once again, is still there. And the top I'm going to leave alone as well. Right, now once you're here, you're pretty much in a good spot. There's one thing left to do. We can bring the negative out front, which is what I'm going to do. And we got an I on top. And if we do the square root of 30 over the square root of 10. Right, so when I move the negative out front, multiplying by 1 does nothing. Just got square root of 10 on the bottom. You can combine square root of 30 over square root of 10 because they're not negative numbers, and division is just the same as multiplication as far as operations go. So we can divide the inside, and 30 divided by 10 is 3. We got negative I in front, and inside the square root we got 3. So for most people, that is the main new thing in this section. If you try to multiply these out, so if you think, oh, I can do negative 2 times negative 5, which would give me 10 in the square root, what will happen is you'll miss this I squared, which is a negative 1, and you won't have this negative sign here. You will get the wrong answer if you don't do it correctly. Always take negatives out of square roots first when simplifying. So the next little topic, adding and subtracting complex numbers. Pretty straightforward as well. Most of you have probably done it. Once again, I'll remind you, if you kind of think about I as x, how would you add these together? And it's really a matter of combining like terms. Right, so this first example, we got 3 plus 2i plus 4 minus I. I'm going to look at the parts without I and add them together. 3 plus 4. And I'll keep it separated for now. And then I'm going to look at the parts with I. We got 2i plus negative I, or minus I. And 3 plus 4 is 7. 2i minus I, just like 2x minus x would be x, or 1x, we get 1i, or just I. And like we talked about before, that is it. You cannot combine things with I and without I. And so this is in a plus bi form. A is 7 and b is 1, if you want to point that out. The one thing you want to be careful about with subtracting is you just don't forget to distribute the negative sign, or however you write it. But other than that, it's the same as adding. We got 2 minus 3. I like to always write a plus and then just make sure I include my negative signs. I got negative I minus 2i. And so I'm combining each part. The fact that I'm subtracting in the middle is only affecting these signs right here. The negative I minus 2i, we have it written 2 minus 3. And simplify that, we got 2 minus 3 is negative 1, and negative I minus 2i is negative 3i. And once again, that is it. Another thing some people like to do, for a plus, you could distribute the 1 through, which would do nothing, so you can just get rid of the parentheses altogether if they bother you. For the minus, if you want to get rid of the parentheses, just distribute that negative 1, and you can totally get rid of them if they're bothering you. So it's 2 minus I minus 3 minus 2i. And that's the same thing as this, just jumbled up. You can simplify it like that if you want. Right, for multiplying complex numbers, it's pretty much, once again, the same thing. Looking down here at this example, if we had 4 plus 3i and 5 minus 7i, and we wanted to multiply them, but they were x's, we would FOIL them out. Well, we want to do the same exact thing here, just like if I was x. The extra thing when you multiply complex numbers is you're always going to get an I squared, and you need to plug in I squared as negative 1. A plus bi form does not have an I squared in it. You've got to make sure you plug that in. Right, but go ahead and FOIL it out. All right, 4 times 5 is 20. And then 4 times negative 7i is negative 28i. And then inside 3i plus 5 is 15i. And 3i times negative 7i, we got 3 times negative 7 is negative 21, and I times I is I squared. Just like x times x would be x squared. Right, once you're here, it's just like the last problem, except you got to make sure you plug in the I squared. That's what I'm going to do first before I do anything else. I squared equals negative 1. I want to make sure I plug that in. Yeah, so I'm not going to combine anything yet. To simplify, we got 20 minus 28i plus 15i. And then negative 21 times negative 1 changes the sign to a plus 21. Oops. Negative 21 times negative 1 changes the sign to a plus 21. Right. Now once you're here, you can combine your like terms. 20 plus 21 is 41. And negative 28i plus 15i is negative 13i. That would be our final answer. One thing you want to notice here, there's no shortcuts. The 41's not obvious how to get the 41 and all 13, same idea. You don't want to try to take any shortcuts, but it doesn't take too long. And I don't have another multiplication problem because this is it. Right, the last thing in this section is division of complex numbers. One of the main reasons we are going to talk about this is because of the complex conjugate, but it's also good to know how to actually divide complex numbers. So we'll start with a complex conjugate definition. So let a plus bi be a complex number, then its complex conjugate is a minus bi. You think about this a few ways. The way I like to think about it is flipping or changing the sign on the part with I. If you haven't done this much before, I would just go ahead and write down one or two of these examples, but it's pretty straightforward. The complex conjugate of 3 plus 2i is 3 minus 2i. Let's just change that plus to a minus. Same deal, if you have a minus, you change it to a plus. The complex conjugate of 4 minus 11i is 4 plus 11i. The complex conjugate of I, you don't have to have a real part here. You still follow the same rule. The complex conjugate of I is negative I. And the last example, just the opposite way. The complex conjugate of negative 12i is positive 12i. Right, so in every single one of these, we're taking the part with I and switching the complex number, or switching the sign. It doesn't matter if there's a real part or not. One thing I would mention is that we don't talk about complex conjugates if there's no complex or imaginary part. So you won't be asked on that. It's not going to be any tricks about it. All right, but for right now, the purpose of the complex conjugate is to simplify division of complex numbers. So the first example we have here, 6 minus 2i divided by 11 plus i. And the important thing, once again, is you want to write it in a plus bi form. You want to simplify this into a plus bi form. Well, in order to do that, you got to get rid of the I on the bottom. And the method to getting rid of the I on the bottom is to multiply by the complex conjugate of the denominator. And so we have a couple examples here. The first thing I would do is just write down the complex conjugate of the denominator. That way you don't try to do anything too fast. But important that you want the denominator, not the numerator. You'll see why when we do it out. In our denominator, 11 plus I, the complex conjugate, we switch the sign in the middle to get 11 minus I. Okay, so what we're going to do is we're going to multiply by the complex conjugate of the denominator. We want to multiply the top and the bottom. Right? We can't just multiply the bottom. We'll change the number just like our old algebra rules. We have to do it to the top and bottom. And so what I'm going to do to really indicate how to do this, our number isn't written in parentheses, but when you multiply these things, as we saw above, it's going to boil down to foiling, and I think putting everything in parentheses helps you realize that. Okay, so we have our original complex number here, 6 minus 2i over 11 plus I, and we are multiplying it the top and bottom by the complex conjugate. Now to simplify this, what you want to realize is you need to multiply the tops together and multiply the bottoms together. It turns into two FOIL problems. But you want to do that first. You don't want to try to simplify anything else. So I'm just going to start by having it separated to make it more clear what we're doing. The tops, we have 6 minus 2i and 11 minus I. We're going to multiply those together. The bottoms, we have 11 plus I and 11 minus I. And we just saw above, the way we multiply complex numbers is FOIL them out. Especially this first step, it's going to look long. Just take your time, make sure you don't rush through it. We FOILed out 6 times 11 is 66. And then 6 times negative I is negative 6i. Negative 2i times 11 is negative 22i. And negative 2i times negative I, the double negatives give us a plus 2i squared. Right, now go ahead and multiply the bottoms out as well. 11 times 11, FOIL them out, 121. 11 times negative I is negative 11i. And then next I times 11 is positive 11i. And the last one, I times negative I is negative I squared. Follow the same pattern that we did when we multiplied for each step. You multiply by FOILing out, and the next immediate thing to do is plug in I squared is negative 1. You gotta do it on the top and bottom here. Right, now I'm gonna, since we've seen that before, I'm gonna go ahead and simplify the middle two parts because these are like terms for each. One thing that should happen every single time, as long as you multiply and by the right thing and FOIL it out, is that the I part on the denominator should cancel. Right, so if you did it right, these should cancel. The 11i and negative 11i do. Now on the top, they may or may not cancel, probably not. It doesn't matter if they do or not. All right, so on the top we got 66. Negative 6i minus 22i is negative 28i. And then 2i squared, when we plug in negative 1, that changes the sign to give us minus 2. And on the bottom, 121. The I and negative 11i and positive 11i cancel out, and we got negative I squared, negative 1 is positive 1. And now continue simplifying each thing. Don't try to interact with the top and bottom yet. So 66 minus 2 is 64 minus 28i over 122. Now, if you can simplify more, you should. One thing that's a good habit when it comes to complex numbers is, at minimum, breaking up a fraction, if you have anything left over on the bottom, into two parts. So what we mean here is we can write 64 over our denominator, 122, then minus 28i over our denominator, 122. Right, break apart the fraction. We can do that as long as the plus and minus are only in the numerator. And then ask yourself, can you simplify the numbers in the fraction. Can we simplify 64 over 122? And we can take a 2 out of each. Take a 2 out of 64, we get 32. Take a 2 out of 122, we get 61. And then same thing for 28 and 122. We can take a 2 out of each. 2 out of 28 is 14. We still have our I up there. And take a 2 out of the 122, we get 61 again. This right here is totally 100% simplified. If you go this far, there's nothing more you can do. But once again, I want to point out, I know this one's definitely much longer process, but there's not really any shortcuts that you want to try to take. Just do it out. If you're careful with the foiling, this rest of this stuff should happen pretty quickly. All right, the last example I have here for division is it looks kind of different because the bottom is only 2i. It has no real part. But we want to do the same thing. We want to multiply the top and bottom by the complex conjugate of the denominator. Now, if you do watch some videos on this, when there's no real part, they might use a shortcut, which is okay. But one thing you really want to try to take in throughout this class, especially for those of you that are going to take calculus, you don't really want to learn specific shortcuts. You want to know how to do a problem in general, and then maybe you work it enough and you realize how to do the shortcut. And so we want to multiply by the complex conjugate of the denominator on the top and bottom, and the complex conjugate of 2i is just negative 2i. So we're going to multiply the top and bottom by negative 2i. I'm going to just write it in parentheses again, even though it's not going to look like FOIL this time. All right, now on the top you need to distribute the negative 2i through. This isn't FOIL because there's not two things over here. It's not a binomial. But we can distribute the negative 2i through. And on the bottom, we're just multiplying 2i and negative 2i. All right, so negative 2i times 4 is negative 8i. And negative 2i times negative 3i is positive 6i squared. And on the bottom, 2i times negative 2i is negative 4i squared. Now it might be tempting because this is a smaller looking problem, but what you want to do immediately is plug in I squared equals negative 1 like before. You do not want to do anything else to try to simplify it. It's too easy to make a mistake. Right, so that's all I'm going to do. We got negative 8i. Plug in negative 1 for, oops. Plug in negative 1 for, right here for the I squared, we get negative 6. And if we plug in negative 1 for the I squared on the bottom, the negative on the negative 4 would give us positive 4. Now once you're here, it's pretty much at this step from last time. We break it apart and simplify each fraction. It doesn't matter if the I part's in the front or the back. If you want, which I'll do at the end, we can rewrite it. Negative 8i over 4 minus 6 over 4. Split up the fraction. And simplify each part now. Negative 8 over 4 is negative 2. So the front part's negative 2i. 6 over 4 can be simplified. Take a 2 out of each to negative 3 over 2. This is a fine answer. Like I said, you can have the I in front or the back just as long as it's with its correct part. If you really like the I to be on the back, you can put the negative 3 over 2 in front and the minus 2i in back. Either one of these is perfectly fine. One is not more simplified than the other. But as far as complex numbers go, this is really all we need to to do what we're going to do in the chapter.